Hello all, welcome to the 𝗏𝗏𝗃𝗃 YouTube channel. In this video, we are going to see the solutions of Codechef Starters 190 Division 4. So, without any further delay, let's get started. So, let's see the first problem statement, that is maximum slams. So, the problem statement says that Shiv is a professional tennis player and his aim is to win more grand slams than anyone ever has. And it is saying that Chef has won X grand total slams in total. Now, Chef needs to win at least 25 Grand Slams in total to break the record for the most total wins. And it's also saying that every year there are exactly 4 Grand Slams. Assuming Chef is enough skilled and always wins a Grand Slam. Now we need to find what is the minimum number of years Chef needs to break the record. So to break the record, how many slams that Chef has to win? At least 25. At least 25, and we are also given a value x, and x is that the slams that Chef has already won. Now let's see the input format. Now the input format says that the first and the only line of input contains a single integer x, which indicates the current number of slams that Chef has already won. Now output format. In output, they are expecting us to print minimum number of years Chef needs to break the record for the most Grand Slam wins. As you have seen, to break the record, Chef needs to win at least 25 Grand Slams. Let's understand the problem statement with an example. And the constraints are saying that x will always be in the range of 0 to 24. Now let's see the first sample input, 0. Now this is a value of x, which is 0. Now what is this x saying? Chef has won 0 Grand Slams. Now he has to win at least 25. At least 25 to break the record. Now how many years does he need? 1 year can give him 4 Grand Slams. Right? 1 year can give him 4 Grand Slams. He has to win 25 Grand Slams. How many years does he need? How many years does he need? So it is nothing but 25 by 4 plus 1, which will give you 7. So this is how we are getting 7. Now let's see the second sample input. Now it is saying 9. Now in this second case, x is 9. Now what is this x here? These are the number of slams that Chef has already won. And in order to break the record, he need to win at least 25. So can I say that he has already won 9 out of these 25? So the remaining slams that he has to win is 16. Right? And how many years does he need? It is nothing but if 1 year is giving him the 4 Grand Slams, in order to win 16, how many years does he need? It is nothing but 16 by 4, which is nothing but 4, which is the expected output. This is an actual problem statement. Now let's see the sample case 1 again. Now if you see, I'm adding plus 1 here. Why is this plus 1 here? Because if I take integer division with 4, I get 6. But if he plays for 6 years, he can win 24 Grand Slams, right? But in order to break the record, he need 1 more Grand Slam. That means he has to bear 1 more here to get this record. So I'm adding this 1 here because he need 1 more year to win 1 Grand Slam, which sum ups to 25. Now, if we try to put this into code, it is as simple as first you need to take the remaining Grand Slams he has to win. That is nothing but 25 minus x. This will tell you the number of Grand Slams that he has to win. Now, if remaining Grand Slams is even, it is nothing but we are going to print remaining Grand Slams by 4, which will give you the number of years that he has to play so that he can break the record. Else, you will print remaining Grand Slams by 4 plus 1 for that fractional part in order to win at least 25 grand slams. Let's try to put this into code. Now let's begin with the code. So as input format says, we'll be given with the value x. So I'm reading it. Now once I read, I need to find the remaining grand slams that chef has to win. That is nothing but 25 minus x. Now I need to see if there is any fractional part. If there is no fractional part, the number of years is nothing but remaining slams by 4 will be the total number of years. If there is any fractional part, that means it is not perfectly divisible by 4, which says there is some fractional part. So to fulfill that fractional part, we need one more year. So that is nothing but I can simply copy this and add plus 1, which shows the fractional part. Let's submit and check. So when we run, we got 7, which is expected output for the input case as 0. Now let's submit it. So it is accepted. So this is the solution for this problem. Now let's go to the second problem statement, which is number reduction. And the problem statement says that chef has an integer x with him. He can perform the following 2 modifications to it. Here 2 it is nothing but x. However many times he likes in any order. That means there is no restriction on these operations. He can do any number of times. Now the first operation says that if the value of x is greater than 3, he can subtract 3 from x. If x is even, he can divide x by 2. Now you need to find the minimum possible value of x can take after performing the given operation several times. Now let's understand the problem statement with an example. Now let's assume the value of x given to us is 13. Now can you go ahead and perform the second operation? No, right? You can perform second operation only if x is even. Now can I say now the only option you have is to perform the first operation? If you do that, what happens to x? You're going to deduct 3, right? As x is greater than 3, which is nothing but 13 greater than 3, you're going to deduct 3 from 13, which results in 10. Now can I say this is a new value of x? Can I say this is a new value of x? Now can I say this is even? As this is even, we can divide the x by 2. Now the new value of x is, which is nothing but 10 by 2, which is 5. Here I have chosen the first operation. Here I have chosen the second operation. As the result of this operation, I got 5. Now, can I go with the second operation? No, because it is odd. Since the number is odd, we have to go with first operation as we have seen in the case of 13. And I am deducting 3 from this, which results in 2. That is nothing but I am going with the first operation. Now, can I say x is even? Yes, x is even and I can just divide it by 2, which is 1. Now, as it is odd, as this is odd, can I go ahead and perform the first operation? No. If you clearly observe the first operation, here it says x greater than 3. You can only perform the first operation only if x is greater than 3. Now, is x greater than 3? No, you cannot go with the first operation. Now, is x even? No. This is where you stop. This is where you stop performing the operations and the result is 1. I hope you understood all these steps. So when the number is odd, you keep deducting 3. If the number is even, you keep dividing it by 2 until and unless you come to a certain point where you cannot apply both the operations. Let's try to put this into code. Out of these 2 operations, we should always give priority to the second operation because it reduces the number by half. Let's understand this with an example. Assume the x value is something like 16. If you apply the first operation, the value of x will be 13. As x is even, if I go with second operation, the value becomes 8. So out of them, which is smaller? Our objective is to find the minimum possible value of x, right? So whenever possible, we should always try to apply second operation. When there is no chance for us to perform the second operation, then go ahead and perform the first operation. Now let's try to code this. Let's understand input format. Input format says that the first line will contain the t number of test cases, and for each test case you are going to get a single integer x. If you see, I have written the t number of test cases followed with the x for each test case. Now I will keep on doing these two operations until my value is greater than 0, and I will perform the first operation only if x is greater than 3 and x is odd. These are two. When these two conditions are true, I will go ahead and do the first operation, that is deducting 3 from x. Otherwise, I'll check if the number is even. If the number is even, I can straight away choose division over subtraction. If none of them are true, I can just break from the loop, which indicates that I have to stop where we have seen this through the explanation. Now at the end, I can simply go ahead and print the updated case. Now let's run it. Now if you see our code's output is matching with the expected output for the sample test case. Let's submit and check. Got accepted. Let's move to the next problem. So let's see the third problem statement, which is min max deletion. Now the problem statement says that for an array B of length m, we define f of B as follows. Initial score is, it is saying that initial score is 0. Now then perform the following operation m minus 1 times. These are the few things to remember. Score is 0 initially, and you can perform the following operations m minus 1 times. It is saying that choose an index I. This is nothing but cardinality of B, that is nothing but size of array B. That's it. So it is nothing but cardinality, that is nothing but number of elements in the given array B. Now you should choose an index I, add minimum of Bi and Bi plus 1 to the score, and then delete maximum of Bi and Bi plus 1 from B. This reduces the length of B by exactly 1. Let's understand this operation. Assume these are the array elements you have, so on. Now if I choose I as 2, it is saying that your score will be increased by minimum of A2 comma A3. That means your score will be incremented by score plus equals to minimum of A2 comma score plus equals to minimum of A2 comma A3. Right? After that, delete maximum of A2 comma A3. That is nothing but you are going to find the maximum out of them, and you're going to delete maximum from them. Not both, maximum of both of them. Now it says that this reduces the length of the by exactly 1 as we're deleting the max from both of them. Now here we chose I as 2, but here the problem statement is you can choose any I. So to put it generic, I'm just writing it as minimum of AI and AI plus 1. Now here it is saying that f of B is defined to be the maximum possible value of score at the end of this process. That means whatever the value we are going to get at the end after all this process is done, that is the maximum we can attain. Now you are given an array of length n. You need to process q updates on it, and in each update you get two integers I and x, and you must set ai as x. That is nothing but you should go to this array. Replace the element at ith index with a given value x. And it is saying that, remember this, updates to the array are permanent. This is very important thing in this problem. Now let's understand the input format. Input format says that the first line of the input will contain an integer t denoting the number of test cases. Each line of the test case contains multiple lines of input. The first line of each test case contains two space separated integers n and q. Q is nothing but number of query updates we are going to perform. That is nothing but the length of the array and the number of updates. Now, second line contains integer n, space separated integer. That is nothing but you are going to get n integers. That is nothing but input of array elements. The next q lines will contain two space separated integers I and x. That is nothing but you need to replace array of I with x for each of these q lines. Now, the expected output format is after each update, for q times whatever the update we are making here, after each update, output on a new line of a value of f of a. F of a is nothing but the maximum score we can attain by doing this operation, right? We have seen, right? So here instead of b is saying that it is a. Now let's see the constraints. If you see the value of x is very high, so it's better to go ahead and store the results in the higher primitive data types. Let's go ahead and store the results in long when we are computing the results. So just to keep things aligned, I'm just highlighting it here. Now moving forward, let's understand with the sample input. Now two test cases. This is a first test case and this is a second test case. Now let's understand the problem statement with the first test case, that is 4 3. So you got 4 and 3 which are nothing but n and q, and you got array of size n which is nothing but array of size 4. You got 4 elements here. Then you have q queries which is nothing but 3, right? And for each query you got I and x. That is nothing but for each of them you have to do array of I equals to x. That means after this is done, once you initialize a of 1 with 4, you need to print the score after this update, and you have to leave that element as it is. As this said, the updates are permanent. You're not going to replace the index value with the original value. You'll just replace 1 with 4. Similarly for the next two queries. So once you replace array of 3 with 2, find the new score. Again, once you replace array of 4 with 1, find the new score. And so on. Now let me take this example here, that is 4 and 3, 2, 1 and 3. Now forget about all these queries. What is the maximum score I can get here? That is minimum of these two, which is 2, which is minimum of these two, which is 1, and minimum of these two, which is 1. So the total score I will attain initially is 4. Initially the score is defined by f of a, which is 4 initially. Initially the score is 4. Now I'm just writing it as score as 4, which is nothing but f of a. Now let's try to update array of 1 with 4. But if you closely observe here, he is going with the 1 based indexing. Let's try to convert this 1 based index to 0 based indexing. Now, as these are following the 1 based indexing, let's convert them to 0 based. As he is saying 1, that means in 0 based it is 0. Now he is saying that array of 0 should be 4, array of 2 should be 2, array of 3 should be 1 in terms of 0 based. 1 based are converted to 0 based. Now array of 0 should be 4. If I give the indexes 0, 1, 2 and 3, the size is 4 however. Now replace the 0 index with 4. Initially it was 3, now I'm going to replace it with 4. Now what you can do, you can compute the score again and you can print it. Right, as updates are permanent, we are not going to change this. Now again, array of 2 with 2, you're going to compute the score again with this method. And again, array of 3 is 1. Again, you're going to compute the score by linearly iterating over the array for each updation. Right? This is the initial array. But is it necessary for us to go ahead and do this for each query? It will increase the time complexity, right? It will increase our TC and we are going to get TLE according to the constraints. If you see, n is 10 power 5, 10 power 5, 10 power 10, we are going to get TLE. We are also having Q as 10 power 5. So in total it is going to be 10 power 5 into 10 power 5 into 10 power 5, which is going to give you TLE. So to avoid that, what we'll try to do is, this is the initial score we got, right? That is 2 plus 1 plus 1, which is 4. Now when I'm updating this 0 with 4, I will try to remove this contribution from this score. I will try to remove its contribution from the score. Now, if I replace this 3 with 4, this is a new array, right? Now, what is the minimum of these two? What is the minimum of these two? 2, right? So, will there be any change for this score? We will not have any change for this score. Now, let's go to the second query. Array of 2 is 2. So, I'm going to replace this with 2. Now, do we have any change to the score? Yes, because previously the minimum was 1. Now the minimum will be 2. So before updating this value, what we have to do is, I should first find the minimum of them. That is nothing but minimum of 2, 1, which is 1. So from this score, I'm going to deduct 1 from this. So this is a score I get. Now I will go ahead and replace that index element with 2. As I have removed something and have replaced, now I should add the new contribution. That is nothing but remove older contributions, remove old contribution, and what is the minimum here? Minimum of 2, 2, which is 2. Now the score here is 3. You're going to add to that, which is 5. Add the new contributions. But if you observe closely, this value is also affecting this score, this pair score. Previously it was 1, you got 1 here. Now as this is replaced by 2, the score of this should also be changed, right? So you will exclude it for both. You will see if this is contributing for left part, you will see if this is contributing for right part. In this case it is contributing for both, so you will go ahead and remove. So initial score was, now let's come from the beginning. So initial score is 4. After the first query we don't have any updates here. Now after the second query the score is 4. Now for the second query the exclusion is 2. So this is a new sum you get. Now addition is minimum of 2 comma 2 and minimum of 2 comma 3, which is 2. So you're going to add 2 and 2, which is 6. Now if you see it is matching with the second query output, as there is no change for the first query even after replacing 4, hence we got score as 4. For the second query, as it is affecting both left and right hand side elements, the output here is 6 for the second query. So we have to simulate this for every query. So we are assuming zero based indexing here. So let's try to put the same thing into code. So let's begin with the coding part. So I'm declaring a scanner object with the inputs. Then as per the input format, I'm going to read the test cases. And then for each test case, I'll get two integers n and q. After this, I'm going to read n elements and store them in the array of size n. So I'm declaring an array now. I'm iterating to read the array elements. Now I'll compute the initial score. As I said, I'm going to store the result in long and the value set to high. So I'm just going ahead and iterating over the loop and then calculate the score math dot minimum of array of I comma array of I plus 1. So I'll go till only n minus 1, n minus 2, because n minus 2 is the last index for which you'll have an element on the right side, or the last adjacent pair you can form. Now once you come out of this, once your control reaches this line, you'll have the initial score. Now you iterate over the q queries, and for each query you will read index. But as we discussed, the given indexes are 1 based. We should convert into 0 based. I'm converting it to 0 based. Now reading the value x that should be stored at that index. Now before that, we need to remove the older contributions, right? So removing older contributions. Removing older contributions. That is nothing but score minus equals to math.mean of array of I comma or array of I minus 1 comma array of I. So this can also affect the right side element. So looking for both sides, the first one is for left side and this is for the right side, or the left element or right element. Array of I comma array of I plus 1. So this is only valid if I is greater than 0, because when I is 0, I minus 1 gives you index out of bounds, and I plus 1 is only valid if I is less than n minus 1. Now we are deducting the older contributions. Now we need to add the new contributions. That is nothing but adding new contributions. Very similar to this. So before adding, what you have to do? You have to replace that element at that index with x. Then take the contributions. If you directly replace, you are not going to remove the older contributions properly. So instead of minus, this is going to be plus. Now after this, we can just print new score. Let's run and check. So I guess it is matching with the expected output. Now let's submit and check. So it is accepted. The verdict is accepted. So let's move to the next problem statement. So let's start with the fourth problem statement, and the title is light all. So the problem statement is saying that 𝗟𝗲𝗃𝗲 jail has n prisons arranged in a row. Above each prison cell is a light. Each light can be made to face either to left or right, but not both. So this is an important point to consider for this problem statement. So there is a light on the top of each prison cell. You can either face it towards left or you can face it towards right, not both. The direction of light should be either towards left or right, not both. Right? Now, the lights are not very strong and so only light up adjacent cells. In particular, let's see that in a better way. If the light at index I is facing right, it will light up the cells I and I plus 1. And if the cell is at index I is facing left, it will light up the cells I and I minus 1. Yeah, this is nothing but not going out of bounds. Now, unfortunately, due to lack of maintenance, not all the lights are working. So you are given a binary string S. It's a binary string consisting of only zeros and ones. It is an indication here, where Si equals to 1. That is nothing but character at that index in the string. If it is 1, means that ith light is working, and S of I is 0 means it's not working. For example, if I take this string, the indexes are 0, 1, 2, 3. That means this light is working and this light is working. This light is not working and this light is not working. Okay. Now the problem statement is ask us to find if it is possible to choose the directions for all working lights so that every cell is lit up by at least one light. Now, as we have these non-working cells and as we can tilt these two working cells either towards left or right, can we somehow make these all lights work? That is a problem statement. Now let's see the input format. The first line of the input will contain integer t denoting the number of test cases. Each line test cases consists of two input lines. The first line of each test case contains a single integer n saying the number of cells or lights. Now the second line contains a binary string s denoting information about the lights which work. So that is nothing but, this is nothing but the string length, that is string s length. Okay, and this will tell that out of all these bulbs or cells which are working and which are not working. The second line will tell us that. Now output format, let's see the output format. For each test case, output on a new line the answer S. if there is a way to choose directions for the lights and light up every cell. Otherwise, no. So here the casing doesn't matter. You can go in the way you want. Constraints are too low, not to worry about the constraints. Now let's understand the sample input output. Let's take this case. If you see, we have 5 lights or 5 bulbs. Out of this is working, and this is working. Now, as the question is saying that if a light is working at index I, it can light both the cell at index I and I plus. Now, if the light at index I is facing left, it will light up the cells I and I minus 1. Now that means in the sample input, for this working cell, do you have anything on its left? We don't have anything on this left. But if you see, this is a non-working cell. This cell is not working. So I can change the direction of this cell towards right. Now that means both of these cells are lit. Now that means both of these cells are lit. Now is this lit? No. Now you will come here. Now is this a working cell? Yes. Now you can shift this direction towards left. Now this cell is working and this cell is working and this cell is working by default. Hence the output is S. Okay. Now let's see the second test case. Now to make this cell work, what do you want to check? If there is any working cell on its adjacent. You don't have anything on the left, but you have something on the right which is working. Now you can change the direction so that now this is working and this is working. Now to make this cell work, you can change this direction towards left. If you change this cell's direction towards left, you can light this up and this is already lit, but this is not lit. The output is no. If you go with this configuration, or let me go one step back. Now, if I choose this cell and move this towards right, this cell is working and this cell is working, right? Even in this case, this is not working. Still the output is no. Now let's see the different configuration. If I choose this cell and if I lit this up, both of these are working. That means this will not work. So if you see, none of the configurations will work. Hence the output is no. Just you can simulate the same process for the remaining 2 examples and you can see the corresponding outputs. Okay. Now here for a working cell, we should just see if there is any adjacent cell that is not working. For this working cell, is there any adjacent cell that is not working? Yes, this is an adjacent cell that is not working. I can light this up. For this cell, is there any adjacent cell that is not working? Yes, I can light this up. Now, for this working cell, is there an adjacent cell that is not lit? Yes. So with this, everything is lit. The output is yes. So that means for a working cell, if character at this index is 1, for a working cell, I should just see if there is a non-working cell towards its left. If this is true, you can lit this cell. Otherwise, but if you see, you can use this cell only to lit either the left side or right side, not both, right? So if this is true, you are not allowed to lit this cell, that is I plus 1. So you can lit this. There are 2 possibilities for us. You can either lit the left cell or lit the right cell, 2 adjacents. Now we are going to lit any one of them. So you will simulate this for every working cell. You should do this for every working cell. And at the end, see if any cell is not lit. If any cell is not lit, print no, else print yes. So if you try to just convert this into code before seeing the solution, before we live code, you could just try it out. So you have to maintain the states. You need to maintain the states of all bulbs or lights here, all cells here, such that you won't overcommit or overlit the bulbs. Okay, so let's begin to code. So as you know the input format, let's directly jump to the sample input. So the first line contains 3 test cases followed with 4 different cases here. So for each test case, you're given with the size of the bulbs and you're given with the states of the bulbs. So 1 says the ith bulb is lit, already 0 says the ith bulb is not lit. Now our objective is to see if we can somehow, with some configuration, can we lit all these bulbs or cells. Now I have done the basic reading part here. Now, as I said, we need to maintain the states of each cell, right? So for that, I'm just declaring a boolean thing state of size n, as we have n cells. Now, I'm initializing or assuming every cell is not lit initially indicated by false. Assuming all cells are not lit initially. Okay. Now let's run the loop over the given string plus. Now if I encounter a working cell, I can use this somehow to lit either the left non-working cell or right non-working cell. So first I will see if I can lit the left non-working cell. S of I minus 1, if it is equals to 0, it indicates non-working. You should not lit a cell which is already lit, right? So for that you need to check the state of this cell. If it is equals to false, which says that it is not lit by any other working cell, that means you can use the current working cell to lit that non-working cell. That is nothing but S of, or this should be state of I minus 1. State of this cell will be saying that this cell is lit, right? Now I minus 1 doesn't hold true when I is 0, right? So just add a condition saying I is greater than 0, right? Now if you are litting this left cell, you can't use the same cell to lit the right one. Like I'm just continuing from here, going to the next iteration. Otherwise I will see if I can use this cell to lit the right cell. That is nothing but if S of I plus 1 is 0, and if it is not lit, it is nothing but state of I plus 1 is, now this bulb is lit, right? One thing I'm missing is ith bulb is already lit, so and that is common for both of these conditions. So I'm just writing it as which is already lit, right? Now after this is done, I'm just declaring one more variable saying can lit. Initially, assuming every bulb is lit. Now I will iterate over this state array and I will check if state of any cell is false. That is nothing but if it is not lit, I can make can lit to false, saying that I cannot lit, I will break. And I will print if can lit is true, print yes. Let's print no. Let's run and see. If you see I plus 1 doesn't work, when I is n minus 1, so I plus 1 less than n minus 1. It holds true only till I has n minus 2. Now let's run and see if we get any errors. So let's correct that. Now let's run and see. So it is not S of I, it is state of I. So I guess it is matching with the expected output. Now let's submit and check. So if you see I plus 1 doesn't work when I is n minus 1, right? So we should ensure that. So I is less than n minus 1. And so we are just ensuring that we are not going out of bounds. Now let's run and see. So our output is matching with the expected output for the sample input. Let's submit and check. So it is accepted for all the cases.
Thank you all for watching the video. If you need more content like this, please like and subscribe to our channel. And if you want to be really good at coding, we also have dedicated courses which we offer. To know more about those courses, you can refer to our official website. See you all in the next video. Bye bye.